back again to this our YouTube channel. This is Mathematics with Engineer Abs. Now today we want to look at the derivative of the sine of x. The derivative of the sine of x. Now I am aware that you know that the derivative of sine of x is cos of x. But how do you arrive at that? How do you arrive at that? So I don't expect your professor to tell you to find that, but I expect you to know the procedure of how you can reach cos of x. Now, we have y is equal to sine of x. So we want to just see the procedure that we can follow so that we get the cos of x. But before we look at it, in case you're watching this video for the first time, please subscribe. That is the only way you can support us. Let's go back here. So let's say that let's put y to be a function of that x. So we have the function of x to be the sine of x. Then, from all the definition of all derivatives, be it cosine, be it sine, be it a polynomial, be it a linear equation, be it a quadratic, all from the definition of the polynomial, we know that the function as limit h is tending to be 0, then we know that function of s plus h minus the function of x over h. So that is the definition that of all derivatives. So the first thing is just to write that formula so that we follow. So we have the function of x plus h minus the function of x over h. That's the definition. So let's have that. So the first thing we know as the limit h is tending to be 0. So can we now put that? So the function of x, that is sine of x plus h minus the function of x, and the function of x is our original value, which is sine of x, then we all over h. But I can see there's something here that you can also see that is coming out, the sum of the total angles. So we know that when you have sine of a plus b, then the identity that we can use here is sine a cos b plus cos a sine b. So that is now what we want to apply here. So we are going to have sine of s cos of h plus cos of s sine of h minus sine of x. This one is all over h. Now this is not hyperbole, you know, this is not cosh, this is just the cos of h. Don't confuse with the hyperbolic functions, no. This is just cos of h, not cosh. Now, but now you can see there's something. You can see we have the sine of x here and here. So I want you to just pay attention. So we collect, let's collect the like terms. So as the limit h is tending to be 0, then we have, let's now collect the like terms. So we have sine s cos h minus sine s x, plus cos s x sine of h. This one is all over h. So what we have done, we have just collected the like terms. So this one we put over the bracket because the limit is to all of that. So what I want to do now here, I want to factorize the sine of x outside so that we have as the limit h is tending to be 0. Then can we factorize a sine x outside? So we have the sine of x into cos of h minus 1 plus this one, which is cos s sine h. This one is all over h. Put of that. Now, so there's something here which is coming out. So what I want to do here is to, because we have the limit h all over that bracket. So I want to break this one into 2, which is the denominator, with the plus. So as the limit h is tending to be 0, then we have sine x cos h minus 1, then break it down over h plus cos s sine of h over h over h. So I want to open up bracket by the limit as h tending to be 0. So you see sine x doesn't have any h in it, so I'll remove it outside. So I'll have sine s as limit h is tending to be 0, then cos of h minus 1 over h plus, and you can also see that cos of x also doesn't have h in it, so I'll move it outside. Cos x as the limit h is tending to be 0, then we have sine of h over h. Now from here, I expect you to know some of the identities here, and please take note that if you have cos of x minus 1 over x, this one is always 0. So this one you can prove with your calculator, that as h, which is the variable tending to be 0, then you equal to 0. This is as the limit h is tending to be 0, then that one is equal to 0. Another one that also I expect you to know is that when you have as the limit h is tending to be 0, then sine of x over x is equal to, can you guess? Is equal to 1. I expect that you know all these identity. I do call them that limit identities. Limit identities. I do call them limit identities. Now, maybe in our next video, we're going to prove these identities. Now, having said that, so we're going to replace back 0 and negative 1, and 1 I mean just there. So we have that one. Now we have, can we now replace? We have sine x, sine x as limit h is tending to be 0, then this one will replace with 0, plus cos x as the limit sine of h over h tending to be 0, then that is 1. So we have derivative of the sine of x over changed x is equal to, so sine of x multiplied by 0, we get 0, plus cos of x multiplied by 1, we get cos x. So eventually now we have sine of x over x is equal to cos x, and that is the derivative of the sine of x. Now, if you've learned something, make sure that you give this video a thumbs up. Never stop learning, guys, because the people who stop learning stop living. Bye bye, and see you in the next video.